static electricity. The universe is made of three fundamental particles: neutrons, which have got no charge; protons, which have a positive charge. Those two are roughly the same size, and you find them inside the nucleus of an atom. And finally, you've got a third particle called electrons. These are the smallest particles that exist. They have a negative charge, and you normally find these on the outside, on the shells of an atom, zooming around the outside of an atom, or sometimes there's free electrons. And these electrons are so small, they're the smallest things that we know exist, that they can move around quite freely, and they are the things that cause electricity. So we're now going to look as to how can you actually make things gain a charge. And the way you make sure that things gain a charge is you knock electrons from one substance onto another. So here is an example we've got coming up, which is basically a balloon. You can see the balloon's got 2 protons and 2 electrons. The human being's got 5 protons and 5 electrons. It should be trillions more, but we can't put them on there. And if you rub the balloon against the hair, what we'll actually find is that the electrons would move between the objects, and actually more go onto the balloon than actually go onto the human. So you end up with a charge of a negative charge on the balloon, because there's more negatives on the balloon than positives, and the human has lost those negatives, so it has got a positive charge because it's got more positives than negative. So that when you bring these two together, what you find is that the positive charge in the human would be attracted to the balloon, and that would have the effect of lifting the hair off the human, because each of the hairs would have a positive charge and they'd be attracted towards the negative balloon. The other way of charging, giving something an electric charge, is by induction. Here's a good example. If we have a balloon that's got a negative charge and we bring it up to a wall, you know that it sometimes sticks. And the reason this happens is as you bring the balloon up to the wall has equal numbers of negatives and positive charges, so it shouldn't really feel any sort of effect. But the balloon has the effect of pushing away the electrons, so they go well away from the wall. And because all the electrons have disappeared, you've ended up with a positively charged wall, and that is known as an induced charge. You've induced a positive charge in the wall, and now the balloon, which is negative, is attracted towards the positive wall. You can see this in nature several times. Here's a quite interesting example. This has happened to me before. It's quite an interesting thing when it does. If you're walking out in a field or whatever, and suddenly your hair stands on end, well, it could be the fact that around you there's a very strongly charged substance. So here we go. What you'll see here is your hair may stand on end, and the reason why it stands on end is there could be a very strong positive charge above you, or a strong negative charge. And this strong positive charge attracts loads of electrons from around you, and those electrons jump onto you. You're just not aware of it until your hair stands on end. And the reason it stands on end is, first of all, some of the electrons are trying to reach the cloud, but more to the point, because your head has got a negative charge and your hair has got a negative charge, they repel each other and your hair stands on end. If that happens, you don't really want to be hanging around, because there's a good chance lightning could happen, and that of course is going to be very dangerous if it strikes you. These are the key words that you need to know. You must use these words whenever using any exam question. Mention the word electrons, friction, repel and attract. You cannot really waffle if you expect to get marks in questions regarding static electricity.